Your CSS doesn't fit. Now, I need a lot of photos of me doing talks. I don't have that many, so if you want to become a paparazzi, be my guest. So these are all the length units in CSS currently. Hands up if you know all these. There's a lot, aren't there? You've used Pixel though, right? Hands up if you use Pixel. Good stuff, good stuff. So I want to start with how big are HTML elements without any CSS? If you're using a line mode browser or a terminal interface, you can actually view web pages in the terminal. And this is how your HTML might look. So if you have HTML without any CSS, I'd say this is the best explanation of what that might look like. But usually when we don't add any CSS, this is how unstyled HTML looks. But that's a lie, because this actually has CSS. This has something called the user agent styles. So the browser by default has a style sheet called the user agent style sheet. And this is just a giant CSS file that the browser has developed over many, many years from the very first web browsers, and very few things have changed. And this styles our web page if we don't provide any styles ourselves. And most sizing of elements in this user agent style sheet, and most styles that people create themselves, use the pixel unit. But how big is a pixel? Well, a pixel falls into a category called the absolute unit. I like to call them print units. And it involves all these guys. So you can actually print documents on the web and it will line up correctly. So we have a centimeter and millimeter and all the American freedom units here. And some weird Q unit, which I've never used in my life. And these all link together. So every unit here links directly to each other. They're all on the same sort of plane of existence. This is why we call them absolute units. So if you're printing a page, millimeter will be a millimeter and centimeter will be a centimeter. But we often use CSS for web pages, which we're viewing on the screen. We're not usually printing them. So how big is a pixel on your screen? Well, of course, we've got device pixels, which is the physical unit on your screen. So right here, we've got device pixels projected onto this screen, and they consist of RGB LEDs. So all these little lights trick your eyes into thinking they see billions of colors, or millions actually. But the issue is, we've also got e-ink here, which is a new technology. So there's different types of pixel technology. And fun fact, pixel stands for picture element. But we have this issue with device pixels where you might have a super old Android device where you can actually visibly see the pixels easily. But you might also have one of these new fancy fandangled retina displays, which the whole point of a retina display is that you can't see the pixels. So we have this different pixel density. Now, if you, in your CSS, declare outline 1 pixel on each of these devices, and if it meant a device pixel, you would not really see it on the retina display, and it would be big on this old Android device. So how do we deal with that on the web? Well, pixel is based on many different factors. So first of all, the device determines how big a pixel should be. It scales based on the pixel density of that display type. And you can also change the size of a pixel through zoom in your browser settings. You can also change the size through your operating system settings, and it should cascade down through to your web page. There's many different ways of changing the size of a pixel in a device. We actually have no idea how big a pixel would be. But this is a definition for the size of a pixel. Seems a bit wishy-washy, doesn't it? So with print, we know exactly how big a pixel is going to be. It's going to line up precisely with how big a centimeter or a millimeter is on that page. But on a screen, we have no idea how big it is. But John Alsop, an Australian web developer, ages ago, when CSS was first coming out, described that control is a limitation of print. So the fact that we don't know how big a pixel is on screen is a good thing, because if we knew exactly how big it was, people with visual impairments wouldn't be able to zoom in anything, because then we wouldn't know how big a pixel is. This is why we have pixel scaling. We have all these different devices that we have to cater to. Moving on from pixel, we have typography units. So what happens if you want to scale something with the size of text? We have all these units. So there's another setting in the browser, different from Zoom, where you can increase the size of text. So you might be able to see all the icons on a web page fine. You might be able to, see all of the spacing, and you don't want everything to be bigger. You just want the text to be bigger because you're not very good at reading the text, or your eyesight's going, or maybe you're having a bad day and you just want to increase the size of everything. Accessibility. We have typography units. And the reason we have so many is all of these cater to different permutations of the text. So M is sort of just the generic size of the font that you currently have. EX, I think, is the height of the X character. CH is the width of the 0 character. So there's all these different precise measurements, and you just have to know these exist. You don't have to memorize them all. Just know that if you want to do a certain thing, for example, I like to size my paragraphs to be 60 characters wide. And that's sort of an easy way of visualizing, once it gets past 60 characters, it starts to look a bit too long. So you sort of pick the best unit for that use case. Line height, obviously, if you want to declare the line height of a certain paragraph, you'd use that unit. So you can relatively control that. Now, typography units are based, depending on where they're used. If you're using M for the font size of an element, it'll look to the parent's font size to base itself off. Whereas if you're using M for padding on an element, it bases it off its own font size. So it might base it off itself or its parent, depending on where you're using it. We've also got the root typography units. So if you have a ton of nested divs and each of them is 2M font size, your text will start to get very big because it is doubling itself each time. So you might want to just base your typography off the root element, which is HTML. So that's the element that the browser sort of declares your user font settings. So it will look to that and it will say, oh, the user wants this font size, so rem will be that font size. I use rem a lot in my media queries because the size of text generally influences how big things get, and how big things get influences when you want them to wrap down and form a new type of layout. So for media queries, rem is probably the best unit, even character, anything sort of based off your typography, definitely the root units, and that will let you change your layout depending on the font size. But what if you want to change your layout based on the viewport? You might have certain elements that you want to be visible right when a user loads your website, depending on whether it's desktop, mobile, anything. The web can even work on smartwatches and TVs at the same time. So that we have all these units, the viewport units. So we've got width, height, block and inline direction. Some weird Japanese writing has vertical text. It's very weird. And vmin and vmax will pick the smaller or the larger value of the two. Quick and easy, you can size things based on which viewport dimension is smaller. So I usually combine that with text if I want the text to scale with how big the screen is. I have a calc with vmin in there so that I pick the minimum dimension to scale the text with, so it's not massive if it's a slim screen. But on mobile, we have all these UI elements appearing and then disappearing. So the issue with small screens is that they're small. There's not much space. So browser inventors got very creative and they decided let's hide some of these UI elements when the user starts scrolling. Let's get rid of the URL bar. Let's hide the home panel. And let's just display the full web content. But what if you sized something to be precisely big enough to cover the screen? Which one of these viewports is the viewport? Oh, let's create a large viewport and a small viewport. So the large viewport is all of the UI elements disappeared. So if a UI element is going to disappear, the large viewport has it gone. The small viewport is the smallest it'll get. So all the UI elements are visible, they're all taking up their space. That's the smallest the viewport's going to get. So now we have all these units. So we've got our traditional backwards compatible units, we've got our large viewport, small viewport, and a dynamic viewport. So the large one never changes if those elements go away. It'll always be what it would look like if they were all gone. The small won't change if the UI elements are there or not. It'll just be when it looks small. The dynamic changes. So once you start scrolling on mobile and those UI elements start to disappear, those units starting with D will change live. So if you want your perfectly positioned Buy Our Product Now label at the bottom of the screen to change when the user scrolls, use the dynamic viewport. And of course, you've got all the same variations of each. My friend Kevin made this site where you can view all the differences between these, and this will be on a QR code at the end. And you can select all these different units and see how they work on your phone or your desktop. But what about container queries? These are coming out. We're doing everything in frameworks. We've got components for everything. So we might not know the viewport of the entire website because we're just making a button. So how do we change the size of certain things inside our button based on the size of the button itself? Oh, we'll have some container query units for that. So let's scale everything as though the container that we have is the viewport. So they follow the same sort of convention where the width and height, etc., are the size of that container that you have created with a container query. We've also got the percentage unit. So this technically isn't a length unit because if I say walk 20% in that direction, 20% of what? So you need to stipulate what the percentage is. So each property width percentage is a percentage of the width of the parent, height of the parent, and so on. Font size, I think percent is the same as an M. So percent of what? So you have to know what property you're using it on, what the percentage means. But that's very useful for sizing things in CSS. We've also got the fraction unit. So fraction I really like with grid because we can say we want this column to take 30% of the width. That's non-flexible. So it will always be 30% of the width. And then these fractions, think of it as the leftover pizza. So once the percentage and the absolute units and everything has all taken their slices, fraction take the crumbs. They take the leftovers. So they're very flexible. They'll say, oh, mate, whatever's left, I don't mind. And we've got a remainder here, 1FR, 3FR. Picture that as just 4 slices. 1FR will take 1 slice, 3FR will take 3. It just takes the remainder of the space. So you stipulate what takes up a precise amount of space, what absolutely needs 30%, and then the leftovers are just given to the fraction. It's a super easy, quick way of aligning things on grid. But it's technically not a length unit because fraction of what? All the other units stipulate what it's relative to. Percent and fraction, you have to tell it. So we've got viewport units, container query units, relative typography units, the root equivalents, absolute units, and technically not length units. So I've covered, this is 51 units now, just for sizing things in CSS. There's your photo. So if you're coding away and you think, How should I size this element? There you go. There's where you search MDN. But don't forget keywords and functions. It's not just units, guys. So we got max width is one. So if that paragraph was max width, it would take up as much space as it can, which it is currently. And don't have time to get into use cases. Min width takes up the minimum width that it can. It squeezes it to the largest word in this case. So it tries to get as small as possible. And we've got calc and max. These have excellent browser support. Everything I've mentioned has very good browser support, except for a few typography units. So calc, you can do this live in the browser. You can combine viewport units with pixels together in the same declaration. Or you can pick the maximum of two values live in the browser. You can say, I want either 5 VW, so the viewport width, or 4 pixels, whichever's larger, and the browser will pick for you. What unit should I use for my use case? Same friend, Kevin. He runs an awesome YouTube channel called Kevin Powell, and he goes through lots of CSS topics. He created this site for us so we can figure out what we're doing and what unit we might want to look into for that. So it's whatunit.com. That'll be on the QR code as well. There you go.